Hi Chemistry, this is Mrs. Ellsworth. What we're going to be talking about today is the pH scale. And the pH scale has different ways of looking at it, but this right here is just a numerical value, but it's not really. It's a logarithmic value. And for those of you that have had logarithms or else logs in class, you're at a slight advantage. And if not, I'll teach you how to take care of the math with that. Okay, well, let's go ahead and look at this. Notice it's got battery acid. This right here is where it's more acidic. As we go more towards neutral 7, it becomes a weaker acid. So it's a stronger acid the further away from 7 that it is. It's also a weak base here because it's close to neutral, and then it gets stronger and stronger and stronger base. Notice they got the word alkaline there. Base, alkaline, same thing. Anyway, so it is a weak base and it becomes more basic or a stronger base as we come over this way. And it becomes more acidic as we go to a smaller number to the left here, to 0. Notice that vinegar is around 3, closer to 4, and that lemon juice is around 2, stomach acid. It doesn't sound like it's very much, but since these are logarithms, it's telling you that stomach acid is 10 times stronger than lemons. Okay, and that's a hydrochloric acid. Okay, it's also, compared to vinegar, it's 10 times 10, so it's 100 times stronger than vinegar. Okay, so pop is about right here, and here depends on what type of soda pop that you're drinking. Anyway, so sometimes people will make comments about, wow, there's just 1 pH off of 1. Well, that's still 10 times stronger. And it's talking about the hydrogen ion concentration, and over here it's talking about the hydroxide ion concentration. So let me talk about that, hydrogen ion concentration, hydroxide ion concentration. There are actually 2 different scales, a pH and a pOH scale, but we'll get into that. But look at this first of all. This is the pH of 0, which is 10 to the 0 power, which is 1. Okay, and that's the hydrogen ion concentration where we're talking about a pH is either, I don't remember if you saw that video crash course, he was talking about pH could have also been pH 3O. And anyway, hydrogen ion concentration, hydronium ion concentration is talking about pH. OH is talking about pOH, and that's not on this scale. Anyway, so right here we're talking about 10 to the negative 1 power, which is, 10 to the 0 power, which is just 1. And this would be 10 to the negative 1 power. Okay, so that's written also as, so if I was going to be looking at 10 to the negative 1 power, I just kind of wanted to remind you of what some values look like. So 10 to the negative 1 power would actually be about 0.1. Okay, oopsie. And let me get a couple more here. Okay, and then 10 to the negative 2 power will be about 0.01. Okay, so that's the hydrogen ion concentration. So it was 1, 0.1, 0.01. Notice that these are off by 10. Okay, and then the next one would be 10 to the negative 3 power, so that's going to be 0.001. Okay, so you see that this is becoming less and less concentrated as we go. Here is what a pH of 7 would be like. It'd be 0.0000001. So now it's getting really dilute of the hydrogen or hydronium ion concentration as you get down here to 14. Oh my, that's very, very, very weak. So 14 has got a very weak value for it. And so you'll notice, though, that the OH scale is just the opposite. Okay, so this would be 1, a power of 1. And so now there's so much more hydroxide ions in here that we're actually talking about it overpowering this much here. And there's lots of hydroxide ions in the solution to have an alkaline component in there. So that this right here be 0.1 for the hydroxide ions, and so it's still really overpowering it. And now it's getting closer to where it's even to to where it's even, so it's not overpowering with OH ions quite as much. And here they would both be 10 to the negative 7, so you'd have equal amounts. So you would have hydroxide ions, hydronium ions, and water molecules all over the place, mostly water molecules. And then you're talking about now the hydroxide ions become very, very little, and the hydronium ions are becoming it's a great amount in there. So it's trying to show how there's a relationship. And notice that each one of these equal 10 to the, if I'm going to add these up, it'd be 10 to the negative 14, because when you multiply these two together, you add the exponent, so it'd be 10 to the negative 14, 10 to the negative 14. They always equal 10 to the negative 14, and we'll find that handy later on. Okay, so here is that pH scale, and notice that under 7 is acid, 7 is neutral, and over 7 is a base. And so when you look at this, this kind of shows that relationship between that number and that negative exponent. Okay, and it also shows some typical things too, like stomach acid, vinegar. Again, they always show those ones. And notice that blood is just a little bit basic. When I used to be a lab tech, we used to take the blood of people who were in cardiac arrest, and doctors would be ordering bicarbs, or else they'd be, to give them a shot to bicarbs would go make it a little bit more basic. And then sometimes they would put epinephrine in there, and so they'd ask for epis and all those type of things to help balance out that pH, to get it more to where it's in the correct values. And it was a delicate balance, and if it's not balanced perfectly, then your heart and your whole system starts shutting down and going into cardiac arrest. It's an interesting thought when you think about how all that cellular respiration for each cell really plays a part into your blood's pH and all of your organs working correctly. It just seems miraculous almost to me. Anyway, then so as soon as we start getting to the higher pH numbers, we're talking about soaps. Okay, here's an antacid tablet that they were talking about there. So antacid means base, and then baking soda. I thought about, well, this is cool. I could have my students go and taste different things at home, because we can't ever taste anything in the lab. And I thought, well, I could have them taste different things at home, but really there is not very much that you can taste that's going to be basic. And this right here, they put so much mint or else fruit flavors in it that you just can't quite notice how bitter it is. Usually, like bases, they tend to suck the juice out of my mouth whenever I notice that I've got them. Like when you eat a grape, the interior seems to be fruity and sour, and then the skin tends to be really, really basic, and it's kind of interesting to think about it that way. But I digress. Let's get back on to task here. Anyway, let's talk about calculating pH, because they don't always fall right on the perfect number. They fall between. And so we have to be able to calculate that. But I recommend that you use a number that you typically know to make sure that your calculations are correct on your calculator. I do that whenever I'm unsure of myself, and so I will go in and use numbers that I know to make sure that I do know my math. Okay, so let's talk about this. So if we were going to go and check out the pH of something, we'd have to have the calculation. Here, this is our formula. To find the pH, you take the negative, so you use the button right down by the decimal, and you take the negative and then you push the button log, and then you go and type in your value for whatever the concentration is, and quite often it is in scientific method. Okay, so you could go and punch that into your calculator, and I want you to double check and make sure that you get that negative value there, because if you remember right, they were negative values in the, let's look right here, there were negative values for the exponent there to be the pH number. Okay, so go ahead and try this one and check it out with your calculator. I think that they're being a little bit too mathy here. Just go and plug it in your calculator and press enter, and you should get a 10 there. Okay. After you do that, go ahead and pause and do that. But then let's go ahead and next check out this one. How would you punch this into your calculator? You would go and punch in negative, and then you'd punch in log. Let me write it up here real quick. I'll pause this and do that. So when you punch that into your calculator, you'd press the negative button down by the decimal again. Okay, and then you punch in log. That's up by the second button on my blue calculator. And then you type in 1.8. And then you have to do the EE, or else it'd be times 10 to the n. I think that yours had, it should have, if like one of the the yellow calculator has times 10 to the n, and then also has a 10 to the x button. 10 to the x means anti-log, and times 10 to the n means scientific notation. So make sure that you understand your calculator and how it works. Okay, anyway, so we type in negative log 1.8, the EE button, which is right above 7 on my blue calculator, then the negative sign again, and then 5. That's as soon as you start putting in a times 10 to something that isn't a calculator that expressly desires that for its notation, you're going to be off by a value of 10 and practically a whole pH number. So beware, beware, beware. Okay, so go ahead and punch this in and make sure that you can get 4.74. If you cannot get that, normally in the classroom I say raise your hand and I go help students figure out how to do that. So we'll have to get a hold of me and we'll have to get a hold of me and figure out, can we FaceTime or do whatever that we can, or else maybe talk over the phone, okay? Anyway, so moving on. Okay, so now I want you to go ahead and practice these two values. It's 0.15, and don't let that freak you out. Now you don't have to do scientific notation. So it's really just the negative log of 0.15 there, and that's pretty nice. So go ahead and punch that into your calculator and see what value you get, and do this one. So press pause now, and let's do that. You notice how close that this is to 0.1, which is about, a pH of 1. Anyway, so you're going to get a value like this when you write that. And then if you remember right, that one lady had such a good explanation of how we go and how we go and express the pH. Anyway, when you've got two sig figs like this, then normally we've got it written in scientific notation. It'd be 1.5, so you'd have it as a 0.8. So it's kind of hard to tell on this one. You can go back and watch her video on that. She was excellent on that, but you would always go by the number of sig figs, and that would tell you what your pH is. But our pH here is so low that I would expect you to give me this value here. But I don't think I'd freak out on that. Anyway, this one has got 2 decimals here, so you need to have your pH to the 10th. It's going to be, a whole number and a 10th. Anyway, so go ahead and punch that into your calculator. Here's how you would go and express. It'd be the negative log of 3.00 times 10 to the negative 7. You would punch it into your calculator as negative log 3 EE negative 7, and then you'd find a value. And now you know you're going to have a value that's around 7 somewhere. Okay, and so that'd be 6.5. It goes to the hundredths here, so that means that you have to have 2 sig figs for your, really means you need to go to the 10th for your values there. Okay, and let's go ahead and move on to another type of problem. Okay, now we're going to go backwards. Now I'm going to give you the pH. You need to tell me what is the hydrogen ion concentration of that. Anyway, when we do that, we use the anti-log button. Okay, take the anti-log. They're trying to tell you how to do all the math, but I'm telling you that you just type in anti-log, which is 10 to the x button on your calculator. Oops, I better get that on the forward side here. Hold on one second here. Order, bring to front. Okay, so it's the 10 to the x button on your calculator, and then you would go and type in a negative and then the pH number. So if they ask you what is the pH is 3.12, what is the hydrogen ion concentration, you would go and type in anti-log, which is 10 to the x button, right? And then you go and type in negative, the negative button down by the decimal, and you punch in 3.12. Okay, so go ahead and do that. Press pause and I'll expose what this is. Okay, so we get 7.6 times 10 to the negative 4 molarity. I don't like the sig figs on that. Don't worry about that for this problem here. Okay, next one. Try and find this one. So go and take the anti-log of negative 8.5 and find out what that value is. Pause it. Okay, so you get, so you're doing the anti-log of negative 8.5, and you should get a value of 3.16 times 10 to the negative 9. Now the pH is around 8, So it's going to be somewhere near 8. Okay, and so that's just one way of looking at it. And we're going to have to stop right here, and we'll have to talk about the relationship between pH, pOH, OH concentration, and hydrogen ion concentration tomorrow. See you later.